Hello, math scientists. Have you ever opened a soda can like this and seen all the bubbles rushing to the top? Or maybe you felt the fizzy tickle on your tongue whenever you eat soda? That is called carbonation. And today, we are going to learn all about carbonation. Let's explore what it is, how it works, and do some exciting activities to learn all about carbonation and see it in action. Before we get going, let's ask ourselves, what is carbonation? Carbonation is the process that gives drinks their fizz. It happens when carbon dioxide gas, that's the same gas that we breathe out, is dissolved in a liquid under pressure. When you open a fizzy drink, the pressure is released through the top and all the gas escapes. And guess what? All those fun bubbles are created. Now let's discover for ourselves. How does this carbonation work? I'm gonna open a few more sodas and we're gonna see just what happens whenever we discover carbonation inside of a drink. Let's try it out. All right, mad scientists, let's check out some real carbonation. I'm gonna put down 3 cups. And in each of these cups, I'm going to pour 1 carbonated drink. The first drink I'm going to pour is a yummy Dr. Pepper. I'm gonna pour it into this cup right here. What do you notice happening? Do you see all the bubbles in my cup? They're still popping. The air and the carbonation that is coming up to the top of my drink is coming out in the form of bubbles. That's 1 carbonated drink. Here I have some sparkling water. I'm gonna pour it and let's see what happens. More bubbles. Let me try one more time. I'm gonna pour it and tell me if you see carbonation bubbles forming. I saw a lot of carbonation bubbles just then. You can still see them. This water is carbonated. It's sparkling. There's a lot of carbonation inside. That's my sparkling water. The last drink I'm going to pour is some club soda. I'm gonna pour it and you can check out just how many bubbles there are in this one. Woo! Even more. This one's a pretty still drink now, but if you look closely, you can see there are still carbonation bubbles at the bottom. So there are my 3 carbonated drinks. Did you see all the bubbles in our drinks here? That is the carbon dioxide gas escaping from the liquid. Isn't that cool? Now, I want to ask a new question. How do we think carbonation is created? Do you know that carbonation happens when carbon dioxide gas is added to a liquid under pressure? When you open a bottle of soda, the pressure is released and the gas forms bubbles. Let's test this out for ourselves. I'm gonna make my own carbonated drink. I'm gonna start with a plastic cup like this. I think I'm gonna add some of my very favorite fruit juice next. I'm gonna add a little bit of club soda. Now I see bubbles. I'm gonna stir it up. There's all the carbonation inside now. If you look at the sides of my cup, you'll notice there's a lot of carbonation bubbles. Do you see all these bubbles along the side of my cup? Those weren't there before when it was just juice. We just made a carbonated drink by mixing juice with club soda. Can you see and taste the bubbles? Awesome! Now that we've learned about that, I want to do a little bit of science behind the bubbles. All right, we know that carbon dioxide is a gas that dissolves in liquid whenever it's under pressure. Well, when the pressure is released, the gas forms bubbles. The bubbles rise to the surface because they are lighter than the rest of this liquid. Then we get carbonation and that fizz, right? Just like when we open a can of soda. Let's try an activity now with a balloon and see how soda carbonates with that. All right, mad scientists. I'm willing to bet you that I could blow up this balloon using a bottle of soda. So here's what I'm gonna do. I'm gonna stretch out my balloon like this just to make sure that it's easy to inflate. Then, very carefully, I'm gonna open you up and I'm gonna fit the balloon over the mouth of my soda bottle. Now I might give it another good shake. I see it starting to inflate. I'm gonna keep shaking it like this. Is my balloon starting to inflate? It is! Look at that go. If I just keep shaking and shaking and shaking, guess what? This whole balloon is gonna inflate. Because what's happening? There's all this carbon dioxide, all this carbonation inside of my soda. It's being released out the top. It has to go somewhere to pop. And with my balloon fitted over it like this, There's nowhere else for it to go but inside the balloon and to inflate it up just like this. I blew up my very own balloon just by using a soda can. The balloon inflates because the carbon dioxide gas escapes from the soda and fills the balloon. Look at what I have. I'm going to show it to you. I have my very own balloon. Now, let's do a little bit more on carbonation. All right, mad scientists, let's do a couple of other experiments that demonstrate carbonation. What I'm going to need for this experiment is 2 plastic cups. I'm going to fill both of them about halfway with water. I'm going to grab some Alka-Seltzer tablets. Before I put it anywhere, I'm going to look at my cups. Let's look at this water. Do you see any carbonation? No, what about when I shake it? No, I don't think so. What I'm going to do now is drop an Alka-Seltzer tablet into the first bottle. Ah, what's happening now? Can you see this one? There's all this bubbles happening. The Alka-Seltzer is disintegrating, and it's putting all this carbonation, all this fizz, all these bubbles into my drink. Look at that. Next to my old water. This one, totally still, clear, regular, nothing happening. This one has all the bubbles in the world. One Alka-Seltzer tablet has completely carbonated this water. Alka-Seltzer is a tablet that helps with stomach aches and heartburn. It contains 2 main ingredients, baking soda, also known as sodium bicarbonate, and citric acid. The reaction between the baking soda and citric acid is what makes the bubbles that you see right here inside. It's a fun and fizzy chemical reaction that helps to release the medicine into the water so it can work quickly. That's what Alka-Seltzer does to water, and that is how I can put some fizz and bubbles into a regular cup of water. Now that we've done that, let's try something new using Pop Rocks. All right, guess what I have? Some Pop Rocks! What I'm gonna do for this experiment is I'm gonna grab a couple more cups of water. I'm gonna grab my Pop Rocks. I'm going to add a small amount of Pop Rocks into each of the waters. Whoa, can you hear that? This one is already totally fizzling. The Pop Rocks are creating more fizz and carbonation inside of my drink. You can probably see the Pop Rocks, all the blue in there, that's my candy, but do you see all the bubbles that they're creating? I'm sure you can see all the bubbles that are happening right now. Wow, this one, not much happening, because did I add any Pop Rocks? Nope, it's very still, until I add a few. And now it's sizzling and fizzling, and you can see all the awesome bubbles forming. Can you see along the side? There's a lot of bubbles forming along the side of my cup because the Pop Rocks have carbonated it. Candy releases trapped carbon dioxide gas whenever it dissolves. That creates the carbonation that's inside my cups. Pop Rocks are a type of candy that fizzle and pop when you eat them. They look like small, colorful crystals, and they come in many flavors, but the candy releases the carbon dioxide gas that is trapped inside during the manufacturing process. And when the candy dissolves, the gas escapes, creating the fun popping effects that you can see and hear right now. Now that we've explored that, let's discover some of the uses of carbonation. Carbonation is not just used for drinks. It has other uses as well. Carbon dioxide gas is used in fire extinguishers, and also baking, and even growing plants. So I want to try a new activity and see if we can discover all the different uses of carbonation. All right, mad scientists, have you ever made a volcano using baking soda and vinegar? Here's what I'm going to do. I'm going to take my cup right here. I'm going to add a little bit of baking soda. Then I'm going to put some vinegar in. You'll see that right away there's a big reaction, and all the carbonation in my drink comes fizzling, fizzling, fizzling up, just like a soda bottle when I shake it. And now it's gone back down, but I've covered the top. I'm making sure that I'm not letting any air out, because guess what? All the carbon dioxide just got inside my cup, and I don't want it to stay. I don't want it to go away. I want it to stay in my cup. I also have with me a lit candle that is on fire. Make sure that if you are ever around candles like this, you have an adult or parent to help you out, because these can be very dangerous. You need an adult to help you out. What I can do is, with all this CO2 that I have trapped inside my cup right now, I can actually pour just air onto my candle and put it out. Watch what happens. Did I put any of the liquid onto the candle? No. With just the air, I put out the candle. So what I did was I mixed some baking soda and vinegar into my cup. They created a carbon dioxide gas which fizzed up and helped put out the fire. The CO2 in here removed the oxygen that my fire needed to keep burning. Isn't science amazing? Wow! We have had a bubbly adventure learning all about carbonation, haven't we? We discovered that carbonation is what makes drinks fizzy and soda so bubbly and fun. It happens when carbon dioxide gas is mixed into a liquid under pressure, and when we open the drink, the gas escapes as bubbles, creating that fizzy feeling that we love. So next time you enjoy a fizzy soda drink, you'll know the science behind those fun bubbles. Keep exploring, everybody, keep learning, and enjoy all the wonders of carbonation science.